Next up, we have Sudhir and Kameron. Where are you guys? Right there. Come to the stage. Tell us about AI and weather and stuff like that. Do you want to plug in?
Yeah, for the demo.
Okay. So you're going to talk and then do a demo afterwards.
Yep, we can do that.
You can do a switcheroo on the laptop. Who's got the mic? Please welcome these guys to the stage. Thank you very much.
Cool. Thank you so much for having us here. My name is Sudhir. I work as an Azure Dev PM with Microsoft New Zealand. And with me, I have Dr. Kameron. And today we're going to talk about one of the problems that NIWA has and how we actually help them to solve this problem. So I would like Dr. Kameron to come onto the stage and talk about NIWA and what is the problem they are facing. And then afterward, I'll probably going to talk about how Microsoft has helped them to solve that problem.
Excellent, thank you. I'll kick off with NIWA itself. Some of you guys may know what NIWA is. We're a Crown Research Institute, and our core purpose is the sustainable management of freshwater and marine resources, adapting to our climate, resilience to weather hazards, stewardship of our aquatic biodiversity, and increasing our understanding of Antarctica and the southern oceans. So we operate as a Crown Research Institute, and we provide services to New Zealand. We have three core sciences at NIWA. In the climate space, we're interested in understanding the climate, impacts of climate change over time, interested in contributing to the global understanding of atmospheric chemistry and dynamics, and obviously natural hazards. In the freshwater space, water quantity, water quality, big issues. And we contribute to the global knowledge in those areas, as well as biodiversity and biosecurity. And lastly, in the oceanic space, we contribute to the global knowledge in the oceans and understanding our oceans and how those are changing and evolving. Now, the problem we're going to talk about today, and some of you may be familiar with this problem in your own industries, we have a lot of paper data, and we use that information really to feed into our reanalyses, and I'll talk about reanalyses in a moment. But with all this data, we need a way to capture that information and put it into our computers so we can actually start to process that information so it can inform our models, inform what we understand about the environment, and inform what we understand about the impacts that things like climate change have. A lot of this data is in image format. We scan this information, and you can see there's 150,000 images of data. It's pretty massive, right? So we see that AI can be a tremendous helper in actually interpreting this information, but there hasn't been really a standard for meteorological data, and there's not really a standard. Well, there hadn't been really a standard for OCR of this data. So we reached out to Microsoft, and we said, oh, this is our issue, right? We have these massive models, numerical weather prediction models, where we need data to feed into these models so we have a better understanding of what's going on, both historically and going into the future. Without that data, information pre-1900 that actually had an impact on our climate, actually had an impact on our planet, we don't have as good of an understanding on that. So going forward, how can we use this information to inform how we adapt to climate in the future? This is an example of some shipping logs and diaries and voyage journals that we have at NIWA. And these have been collected over time, and they really do start to fill that gap of understanding that information. But that's stuff that we wanted to get digitalized. So I'll pass over to Sudhir, and he can talk about some of the projects that we work on.
Sure. Thank you. So when we come into the picture, we basically, the first thing is we actually want to see what is the data is all about. And if you look into the data that we receive from NIWA, this is how the data looks like. And there are a lot of nuances on this data. One of the problems that we have seen is when we're actually scanning all this data, over the period of time, initially we have seen the writing is pretty good, but over the period of time, it's going from bad to worst, actually. Because think about somebody sitting somewhere in the coastal garden, writing the weather information on a daily basis, right? that's the one thing. The another problem that you see over here is overriding, right? That's another problem that we have seen. And there are some, as you can see over line over here, that's another problem that we have figured out. And the reason is, when you're going to train your machine learning model, or maybe if you're going to send this information out, whether it's going to consider this as an line or is a number one, it's a problem, right? So these are the kind of a problem that we have seen. And my colleagues earlier and our lovely MVPs also talk about the cognitive services. So what we said, okay, we have a lot of good data which is available. And what we can do is we can actually look onto our OCR, the computer vision technologies, and see how best these services can work, right? So if you have the clean data, which is pretty good data, we can actually go with the OCR route. Now, wherever we have the problem with the data, right? For example, somewhere is 7, but what we have seen over the period of time, the 7 becomes 4, or maybe 7's become 9, right? I mean, and you can't blame the person who wrote that, right? So these are some of the nuances that we said, okay, we're gonna handle in a different way. So this is the reference architecture that we come across, and what we say is, as soon as NIWA is gonna push the documents onto the Azure Data Lake storage, what we're gonna do is, we're basically gonna spin up a function, which is a serverless app that we have. And one of the reasons of choosing the Azure function is, it's basically gonna reduce the cost of the execution, because this is a serverless environment, right? So we're gonna get cost based on the execution time. So if my code is gonna run for 5 minutes, I'm just gonna charge for 5 minutes. And I don't have to bother about it behind the scenes, what operating system is required and all this stuff. That's not my headache, right? So we use that. So as soon as the ADLS is receive the data, the function is basically talking to the ADLS, and it picks up the information, and then it basically figures it out which side is gonna send this information. So you can see we have the cognitive services. So that means the data is pretty clean. We can send to the OCR. If not, then what we're gonna do is we're basically gonna use our Azure machine learning tools to build a custom machine learning model, and then containerize it and send it to the Kubernetes services for the deployment, and use that service to get all the information. Now, once we get this information back, either we are using the custom vision model or OCR, it's basically gonna give the data back in a JSON format, right? And that's where the another block that we hit. For example, if I go back over here, as you can see, the data is pretty consistent in all the columns, right? But what happens is sometimes we have seen the data is there till 4th column, and then the 5th column there's no data. 6th doesn't have any data, and then the data is available in the rest of the columns, right? Now, when the data comes back in a JSON format, it's pretty hard for us to figure it out whether the data, which is on the column number 8, it's basically part of the column number 8, or is a part of number 7 or 6, right? So that's the another problem that we encounter. And what's gonna happen is, I'm gonna show you what we did. But then at the end of the day, once we get all this data, we have this engine which basically convert the JSON into the row column format and dump this data into the SQL, so that the NIWA guys can actually go and do the advanced analytics and do the machine learning models on top of that. And that's where the Power BI reporting is coming into the picture for looking into the data. Okay. Now we're gonna see this information in real time, so I'll just go back. And so this is the entire form, as you can see, that we get it from NIWA, right? And initially when we did a code with engagement with NIWA, we actually said, okay, let's go ahead and take the first 13 columns, run through our OCR, and see how good we're gonna get this information. So we basically quickly spin up an Azure environment, and you can see this is a notebook environment that we have spin up. Wrote some lines of code over here, which actually calls the Cognitive Services API, and then it basically takes that image, get the results back, and draw the bounding boxes against the number that it basically recognized. So as you can see, it basically gives all this information right over here, right? Now, if I go back, the same information, as you can see now, we have got all this information back from the OCR. Now, to write this entire code and convert into this, is basically takes us 2 days, okay? So the code that you have seen in the notebook and understanding it, converting it through the OCR, it give us this results in 2 days. And now we basically build a business engine as well, which basically gonna transform this data and store into the SQL Server. So that's the power of the cognitive services, right? So if you have the data available, you can actually go ahead and spin up the service, get the API endpoint, send this data, and get the results back. So this is, yeah, so if I zoom in, you can see this, all this data that we have received. And it's pretty much get all this information. There are certain nuances, but then it's did a pretty good job to get all this data back to the user. That's all from my side. Anything else you want to add? No? All right, so we are good. Thank you.